So for the computer systems for the module, we've selected two different computers. One the Raspberry Pi and the other being Arduino. We'll probably have multiple Arduinos in fact, but we selected each one for varying reasons for what they'd be used for. The Raspberry Pi for its Linux operating system, enabling process threading and forking, multiple processes running, more complicated operations such as a lot of the data that we'll be collecting from the Arduinos, the data we'll be aggregating and doing processing with, and also the imaging. We'll be hooking cameras up to the Raspberry Pi. It's going to act more as the master of the entire system. And then for the Arduinos, we picked Arduinos for the individual control systems because their usefulness as embedded systems development platforms, their open source nature, which means a lot of support from the community, the high level and high number of ADCs or analog digital converters located on each one, and certain Raspberry Pis have a large number of GPIO pins. So we've been looking at the Arduino Duo, for example, because of that. This is a schematic, I guess you could say, a rough draft of what the control system, both for the power supplies involved here with relays and the actual MCUs or Arduinos, and the Raspberry Pi as a master is going to look like. We see the way we want to implement it is with each of our main systems being controlled individually by an individual Arduino, but the set points and the data aggregation from those Arduinos or for each system is being handled by the Raspberry Pi, which is again the master of the system. Same thing for the relays. We plan to control any, say for example, the temperature inside the environment of the container. If we want to adjust the temperature, we plan to adjust it via a heating element, which will be controlled off of a relay that's controlled via the Arduino itself, but at the same time the sensors feeding back the temperature are coming from, or directly into the individual Arduino as well. So it kind of removes the Pi from the Arduinos, lets the Arduinos tackle that specific process, while the Raspberry Pi is free to handle whatever kind of bigger operations it needs to and doesn't bog down into the other environment controls that we have. Here's an example of kind of the implementation we plan for the controls. You can see that on the Arduino, we're going to run a continuous main loop. It's just running forever. It may interact with the Pi at certain points where it may be, there may be a request to change the set point for a certain metric that we're measuring within that control system, as well as periodically it may want to send data from the Arduino back to the Raspberry Pi. But then ultimately the PID loops will be ran, and that's going to obviously look like your traditional PID construction. We know that some of the environment controls will not be using more sophisticated PID loops, may just be a PNI, or we may, even for certain things like the heating element, we know that it needs to stay off after it's been on for a certain period of time so we don't burn out the element. So there's that to take into consideration, as well as we know that certain systems or certain things that we'll be controlling will be more of like a packet quantized type delivery of whatever, let's say water. Maybe we spit so much water out, but then we just cut it off and we have to wait because of the lag time to find out or get the response back from the sensors to know if there should be more to dose. So this is just, again, just an example of one, but we plan a couple different implementations.